In this problem here, you can clearly see there's a cumulative frequency diagram, so let's read this scenario here. The final examination in percentage results obtained by a group of 3,200 biology high school students are summarized on the frequency graph, the cumulative frequency graph. Okay, and so it says, using the cumulative frequency graph, find the median of the examination results. Well, in order to find the medians, you have to imagine these 3,200 students are all arranged from highest to lowest. So the highest score, it looks like, is a 0, and the highest one is 100. And so maybe there's like 1 0 and a bunch of 10s and 11s and some 11s and some 12s and then some 30 and 31s and 31s again, all the way up to 100. Okay, and so there's 3,000 of these scores. And we're looking for the median. We're looking for the middle person. So we're looking for the student that is the 1600th student if I arrange all these numbers. Well, if I go here, if I take a look at 1600, if I find my 1600, which is going to be there, and I come down from there, I can see that the student's median score, I have to get 1600. These go off by 50, so there's 1600 there. If I find the median score, I can see the median happens at 60. And so the median score is 60. Now I want the interquartile range. And the interquartile range is Q3 minus Q1, where Q3 I know is a 75th percentile. So if I take 3,200 and times it by 0.75, I get 2,400. So I'm looking for the list of all these students, the student that would be 2,400. So if I find him, I take this thing here, there's 2,500, go back down 2 squares, and then I move over this way here. Well, I can see, well, that's 60, that's 70, they're going by 2, so that's going to be 68. My Q3 is 68. Similarly, I'm going to do the same thing for Q1. It's going to be 800. If I go half of 1600, I know is 800, so there's 900 there. Here is 800. And if I look at where it crosses here, it's going to be 48. And so it's Q3, 68 minus 48. So the IQR is 20. Is my IQR, a measure of spread, how spread out the numbers are. It says one student scored 100% on this examination. Determine if the student is an outlier. Well, what we have for outliers is we have a formula. It says 1.5 times the IQR, and it is going that value, so it's going to be Q3 plus that value. This is the upper boundary. Similarly, there's a Q1 minus this value, and this is equal to the lower boundary. Okay, so when I do Q3, which I know is 68, times 1.5 times 20, I have to fix that. Plus 1.5 times 20 gives me, this here gives me 98. And so that says that's the upper boundary. Anything higher than this value is an outlier. Since 100 is higher than that, so therefore 98 or 100 is bigger than 98, so outlier here. And so this formula here is not in your formula booklet, you just need to know that, but that's how we find out if it's an outlier. The upper end outlier, similarly with the bottom end outlier. So now we're told 350 students obtained the highest possible grade. So maybe they got a 7 if they're IB students. Okay, so find the final examination result required to define the grade boundary of the highest possible grade. So from what value to what value is the grade boundary? Well, the highest one's going to be 100. Well, where's this bottom end of the grade boundary? So 350 students met this. So I know if I go 3,200 minus 350, so the 2850 student is where the grade boundary exists. So if I go, here's 2750, 2850, this value here is where the upper grade boundary is. So if I look there, that is a 76, and so I know that a 76 is where the grade boundary exists for the highest grade band. Okay, so now the group frequency table summarizes the examination results as shown. And so we have between 0 and 20 and so on as shown. We want to estimate the mean examination result. The reason why it says estimate is because we don't know what these numbers are. Maybe there's like 149 zeros and 120. We don't actually know how it's distributed within there. And so because of that reason, we just take the mid value. We take 10, and we take 30, and 50, and 70, and 90. And we go to our calculator, we put it into our calculator, and I put it into L1 already. And then our frequency list, so basically we're going to say there's 150 10s and 350 30s, and so on and so forth, even though it could be a different range of values, which we're pretty sure it's not 10, but that's why it says estimate. So to do this, I have my frequency in L2, so I'm going to go stat, calculate, one variable statistics. So I'm only talking about examination results. Frequency is not a variable, it's just a count of how many values. One variable statistic, L1, my frequency list is going to be L2 this time. I hit enter, and here are my values. I get 57.2, rounded to 3 significant figures. And then be careful here, for find the standard deviation of 3 decimal places. Well, there's 2 values here, and the reason why they want 3 decimal places, they want to know if you know which one to use. And we want to use this sigma notation. This 3,200 is the entire population, and so this value is the actual standard deviation of all 3,200 of these students. All these test scores, this number here is the actual standard deviation. So that's the one that we're looking for. The other one up above, this one here is, imagine if this was a sample of a larger population, let's say 1 million people. Well, this value is still the standard deviation of this 3,200, whereas this S standard deviation would be the estimated standard deviation population of the population, where this was a sample. And we're going to have to distinguish between those in about a month's time. So this time we have sigma, because it's the actual standard deviation of these values we're looking for. So in D part it says the teacher sets one grade boundary, sets one of the grade boundaries one standard deviation below the mean. So below the mean is going to be 57.2 minus 18.496. So if I go 57.2 minus the 18.496, I get 38.7. So this is the score that I obtained, 38.7. So if I take my red thing here, see, can I put this back? Okay, and if I take this one as well, I'm looking for 38.7. Well, there's 38. So the 38.7 is going to be somewhere in here, somewhere in this region. And so if I look down here, I want to go in here somewhere. And so if I look here, it looks like it's going to be 450. And I would have accepted a range, but there's going to be 450 students that are in this bottom grade boundary. Finally, E part, the university accepts 6 students from this group to attend the university. They wish to determine if the score on the biology exam is a valid indicator of future performance at their university. The result of the 6 students in both high school and university are shown. State the name of this type of validity. This is criteria validity. because we're seeing, is this a good criteria, this high school biology exam, is it a good criteria to judge how they're going to do? So it's a predictor. So whenever you have this idea of using something as a predictor, it's criteria validity. Is it reasonable or not? Well, in order to do it, it says calculate the Pearson's product moment coefficient of this data. So I'm going to put these points into my calculator, which you can see I put them into L3 and L4, and I do the regression on it. And when I do my regression on L3 and L4, 2-second L3, L4, I get the R value is 0.988. Hence, determine with a reason if the new examination is a valid indicator of future performance. Well, the R value is super strong, and so what I know then is because it's high, it shows a strong correlation between scores, so it appears to be a good predictor for the university of future scores. Whenever you see this command, hence, you have no choice but to refer to your previous result, which I did in my response. So statistics, there's a lot involved with statistics that you have to consider. It's not super hard, but it does take some insight and some sophistication to look through all the nuances, and it takes some practice.